In this video, we will review several commonly used criteria of spontaneity and unify all of them based on the concept of chemical potential. We learned this before. In an isolated system, entropy can only increase. On a constant temperature and volume condition, the Helmholtz energy of the system A can only decrease. On a constant temperature and pressure condition, the Gibbs energy of the system G can only decrease. Now we'll combine all of them into a single inequality expression. First, let's look at the definitions of the chemical potential. This equation, dG is equal to negative S dt plus VdP plus the sum of mu I dNI. This is based on the UPAC definition of the chemical potential. We can easily derive three other equations because H is simply G plus Ts, U is H minus PV, and A is U minus Ts. So we have a total of 4 equations that involve this chemical potential mu sub I. And we can actually move this TdS term, PDV term to the left hand side, and then we get the sum of mu I dNI is equal to du minus TdS plus PDV. We'll write it here. And also we can use this equation. We get the sum of mu I dNI is equal to dH minus TdS minus VdP. Similarly, the sum of mu I dNI is equal to dA plus SdT plus PDV from this equation. The sum is dG plus SdT minus VdP from this equation. Why do we need all these equations? Now let's get back to the criteria of spontaneity. Under constant TV condition, we learned that dA must be negative. Now look at this equation. On a constant TV condition, dt is 0, dV is 0, then dA is simply equal to the sum of mu I dNI. Because dA must be negative, the sum of mu I dNI must be negative. On a constant temperature and pressure condition, the criteria is dG must be negative. And again, on a constant temperature and pressure condition, dt is 0, dP is 0. So dG is equal to the sum of mu I dNI. We draw the same conclusion. On a constant TP condition, the criterion of spontaneity is also the sum of mu I dNI being negative. In general, regardless of the condition of the system, the criteria of spontaneity for a closed system is always the same. It's this: the sum of mu I dNI must be negative. And from the previous page, we learned that there are 4 different expressions for the sum of mu I dNI, and this must be negative. That means du minus TdS plus PDV must be negative. dH minus TdS minus VdP must be negative. And this must be negative. This also must be negative. So we have these 4 inequalities here. Again, du minus TdS plus PDV must be negative. And then we have 3 more in terms of dH, dA, and dG. Now let's look at the first 2. When entropy and volume are constant, du must be negative. U cannot increase. The internal energy of the system must decrease until the equilibrium is reached. When entropy and pressure are held constant, then dH must be negative. H can only decrease. However, constant entropy conditions are rarely encountered. That's why we often look at A and G as the criteria of spontaneity. On a constant TV condition, we know dA must be less than 0. On a constant TP condition, we know dG must be less than 0. And therefore, we have a unified expression here. The sum of mu I dNI must be negative. The sum of mu I dNI must be negative on a constant TV condition, on a constant TP condition. Finally, for a constant energy system, that means du is 0, That means dq plus dw is 0. And because the sum of mu I dI is du minus TdS plus PDV, we learn this must be negative, du is 0, and then therefore TdS must be greater than PDV. For example, if we have an expanding universe, and let's assume the energy of the universe is a constant, and then we have TdS must be greater than PDV, and dV is greater than 0. Therefore, TdS is greater than 0. This inequality can be further reduced to TdS greater than 0 or ds is greater than 0 if the volume of the system is held constant as well as u.